Hi there! Today's video is about IntelliJ IDEA's support for test frameworks. IntelliJ IDEA supports multiple Scala test frameworks such as Scala Test, MUnit, Specs2, UTest, as well as JUnit. The support includes running tests conveniently from different places, debugging them, viewing the results, comparing the results with expected values in a div viewer, code coverage, and profiling. Let's talk about all of that. To run tests, we first need some non-trivial example projects. The first is Ox by Software Mill. Ox is a next-generation streaming library for Scala 3. It lets you perform complex concurrent computations, handle errors, schedule tasks, and more. Let's open the core module and select the test subfolder. We can run all the tests in the module by right-clicking the subfolder in the project panel and selecting Run. Alternatively, we can open any test file in the editor and use the getter icons. This one runs a specific test, while clicking on this other getter icon runs the entire class. The icons themselves will change depending on the test status. We can use the goToTest action to jump from production code directly to the test suite for a given class or method. For example, let's go to the chunk class, place the caret on the drop method name, and use the shortcut Command-Shift-T on Mac or Ctrl-Shift-T on Windows and Linux, which is by default connected to goToTest. This opens a list of test suites that cover this class, and we can select one of them. In this case, chunk test. The feature depends on the standard test naming convention when the test class has the main class in the prefix. The action is also available in the context menu under goToTest. Let's create a new test in chunk test Scala. We will call it "It should create a wrong chunk from JSON." It will compare two JSON strings, but we will introduce some errors on purpose to show what happens when a test fails. Done. Okay, let's run it now. The test fails, obviously, and the Run tool window opens automatically. The right-hand panel shows the log messages generated during the test run, along with the information about our failed assertion. Further down, we find a link. Click to see the difference. By clicking it, we open the div viewer. As the link suggests, it shows the difference between the expected and the obtained result, only on a bigger display and in a clearer way with the actual differences highlighted. Blue for modifications, green for missing chunks, and gray for additional ones. It's especially useful when our tests operate on large strings or collections. By the way, thanks to the language injection feature in IntelliJ IDEA, adding these two little comments, //language equals JSON, highlights the contents of the strings as JSON. We can now fix the code and rerun the tests. Notice that the panel only shows the test that failed. If we click the Rerun button, all tests will run again. Alternatively, we can rerun only the failing tests. Then there are two buttons, one for showing the tests that passed and the other for displaying ignored tests. In Scala test, we can ignore tests by adding the ignore annotation to the test class. For example, we can ignore chunk test and run all the tests in the folder. Tests in chunk test won't run this time, but they will still appear in the list. We can ignore a specific test as well. It requires changing the in method call after the test name to ignore. Let's do it now. We open another test suite, collect part test, change in to ignore in just one test, rerun the tests, and we can see that only this one test from the whole suite was ignored. Please remember that in some other test frameworks, ignoring a test or a test suite may work differently, but if the test framework is supported in IntelliJ IDEA, the ignored tests will be handled in the same way in the Run panel. Next, there is the Sorting Options button. We can sort test results alphabetically by test name, by declaration order, which is how it is done now, or even by test duration. Additionally, tests are grouped into test suites, and these suites are sorted using the same criteria as the tests themselves. The last button here lets us view the test history. We've already run the tests a few times, now we can go back and review those results. For example, to compare them with new results after making some changes. By the way, again, if we use the same unit test framework in many of our projects, it might be helpful to create a live template. To do this, let's go to Settings, Editor, Live Templates, and add a new entry under Scala. Let's call it stest and set it up like this. Now we can create a new unit test by typing stest, selecting the template, giving it a name, and pressing Tab. There are several ways to run the test suites. Probably the most popular one is the one we've already discussed, by using getter icons. We can also right-click on the implementation of a single test and choose Run from the context menu to run that single test. Similarly, if we right-click outside the test, but still within a test class, we can run all tests in that test class. And if we had an abstract test class, we could click right on it to run tests from all the classes implementing that abstract class. Then, in the project panel, we can click right on a single test file or class and run all the tests in that file or class. Or we can click right on the folder to run all tests in all classes in that folder. And on top of all that, if we put the caret inside a test implementation or in a test class outside any test, we can run them with a shortcut Ctrl-Shift-R on Mac, or Ctrl-Shift-F10 on Windows and Linux. The same works if we select a test, test class, or folder in the project or structure view. Before we discuss run debug configurations, I'd like to quickly show you how tests written in other frameworks are supported. Here's the second code example we're using today, an implementation of a binary tree in Scala 3. The project is divided into 5 submodules, each containing the same production code in a file called tree Scala, but with different test suites: Scala test, JUnit 5, MUnit, Specs2, and UTest. We've already discussed Scala test, so we will skip it now, and to show you the other 4 I will use the split screen feature in IntelliJ IDEA. Although the syntax for writing unit tests differs across the frameworks, IntelliJ IDEA recognizes them and lets us handle them the same way. By the way, we can of course run a test in debug mode. Let's take a look at this. Here's the balanced method in the tree class. A binary tree may become unbalanced if, when adding new elements, consecutive elements fall predominantly on one side. This leads to suboptimal search times, so after adding new elements, it may make sense to balance the tree. We put a breakpoint inside the loop that builds the balanced version of the original tree and run the test in debug mode. The program stops at the breakpoint. We can check the values of all fields and variables involved in the algorithm and click the Step Over button a few times to see how the values from the original tree are picked up and added to the new tree. Since unit testing is closely related to debugging, I encourage you to watch our other 2 videos on the IntelliJ IDEA debugger. Their thumbnails should now appear on the screen, and you'll also find the links in the description. In IntelliJ IDEA, the support for test frameworks involve, among other things, run configurations. We can prepare such a configuration from scratch in the Run Debug Configurations window, or IntelliJ IDEA can generate it when we run a test suite for the first time from the editor or the project panel. Let's click on the button in the top menu, the one with the test suite name, to open the Run Debug Configurations window. Since we have already run all the test suites, IntelliJ IDEA has already generated configurations for all the test frameworks we used. The configuration panel looks almost the same for all of them, except for JUnit, which is a Java first test framework and is handled differently. For this video, we will focus on Scala test, specifically the main configuration fields common to the other 4 test frameworks as well. If you want to learn more, you can check out our help pages on Run Debug configurations. In general, Run Debug configurations are not just for running tests. If we click the plus button in the top left corner, we will see all the possible configurations. For example, a new SBT task. But today we focus only on unit testing. In addition to adding or removing a configuration, we can also copy an existing one with modifications. Let's select one, say Scala test 3 suite, and click the copy button. A new configuration of the same type is created. Test kind lets us choose whether to run all tests in a package, only tests in a particular class, a test with a specific name, or all tests matching a certain regex. By default, the output follows how the tests are run in the Run tool window. If we select the Use SBT checkbox, the SBT console will be open instead. If we check Use UI with SBT, the SBT console output will be visible within the Run tool window. If you need to modify the test environment, you can use these fields below, such as VM options, program arguments, and others. They are described in detail in the help pages I mentioned earlier. Below these fields, we can see the before launch list. Here we can specify tasks to execute just before running the tests. Building the project is the most common. If we modify the code, we need to compile it before testing those changes. Other possible tasks are available under the plus button. Most aren't as commonly used as build, but we might, for example, want to open a web browser or run an SBT task to set up the test environment for a specific scenario. Additionally, if you select the Show this page checkbox, running the configuration will only open the Run Debug configurations window for this specific configuration. This lets you review the fields one last time before clicking Run. Or, instead, you can click right on the getter icon for running the tests and select Modify Run Configuration. This solution might be, in fact, even more agile than selecting Show this page. By the way, if we click the small downward arrow next to Run, we will see 2 additional options: Run with Coverage and Profile. If you choose Run with Coverage, the tests will run as usual, but in addition to running the tests and gathering their results, IntelliJ IDEA will also calculate the percentage of production code covered by the tests. Let's do it, but first, to get some more interesting real-life results, let's switch back to Aux and run all the tests. Done. The coverage panel on the right opens automatically after the coverage is calculated. You may also notice a new icon on the right-hand bar. We can use it to close and open the panel again. The coverage results can be sorted by each of the visible columns, and they can also be exported to a file. In a similar vein, we can run a test or a test suite in the profiling mode, either from the Run Debug configurations window or by clicking right on the getter icon and choosing Profile Test with IntelliJ Profiler. The test will run, the Run panel will open, and we will see a suggestion to jump to the profiler to see the profiling results. Look, the test took a long time to run. Something is wrong with it. Let's investigate. We open the profiler, click on the call tree, switch the operation times from CPU to total, and click main in the list of threads on the left. From the values displayed in the editor, we can already see that this test took 7 seconds. And we can even see that those 7 seconds were spent on this single line. We can also confirm it in the profiler panel by unfolding the call tree. It's the tree balanced method that's taking so long. What's that? Is there a call to thread sleep in that method? Let's check. Well, yes, it looks like someone left a thread sleep 1000 call in the while loop. Now we can optimize our code by removing it. That's all for today. Check out more videos on our channel, like and subscribe, read our blog, or chat with the development team on our Discord server. Links to all these resources are in the description. Happy developing!